Chapter 8 is all about quadrilaterals or four-sided figures. But first, we will talk about polygons in general. So in section 8.1, we are going to talk about the angle measures in polygons. So this section starts with a theorem. Theorem 8.1, polygon interior angles theorem. It says the sum, which means to add them all up, of the measures of the interior angle. So interior means the angles inside of the polygon. Of a convex, so remember convex means that all the sides are pushed out. Concave would look like this, so we're not talking about concave polygons like that. So of a convex n-gon, so where we have an n-sided figure, is n minus 2 times 180. So n is the number of sides in the polygon. You need to write down this formula in your notes, star it, bold it, whatever you need to do, highlight it. N minus 2 times 180 will always give you the number of degrees inside of any polygon. So again, make sure you jot down that n is the number of sides. The corollary to theorem 8.1 is the interior angles of a quadrilateral. It states the sum of the measures of the interior angles of a quadrilateral is 360. This is because if I take a four-sided figure, I can divide it into two triangles. And remember, triangles have 180 degrees. So it'll be 180 degrees here, 180 degrees here. 180 plus 180 is 360. So for sure write down this formula and then make a mental note or a side note that all quadrilaterals or four-sided figures have a sum of 360 degrees of their interior angles. So let's put that theorem to use. So here's example number 1. Find the sum of the measures of the interior angles of a convex decagon. So first off, a decagon is 10 sides. So this is where n equals 10. So we're going to use the formula n minus 2 times 180. So this would be 10 minus 2 times 180. So 10 minus 2 is 8. So it'd take 8 times 180 to get the number of degrees in a convex decagon. So I ended up with 1,440 degrees inside of a convex decagon. Let's look at example number 2. The sum of the measures of the interior angles of a convex polygon is 2,340 degrees. Classify the polygon by the number of sides. So this time it tells me that the sum is 2,340. So we're going to work backwards. So we're going to take our formula n minus 2 times 180 and set it equal to 2,340 since we know that is what the sum is. So now we're just going to work backwards and solve for n. So the first thing I want to do is I just want to get the n minus 2 by itself. So I'm going to divide by 180. So if I divide by 180 over here, those would cancel. So I would divide by 180 over here. So I'd have n minus 2 left on the left-hand side equals 2,340 divided by 180 is 13. So then I would just add 2 to both sides. So it'd be n equals 15. So it says classify the polygon by the number of sides. So this would be a 15-gon because there is no specific name for a 15-sided polygon. Example number 3 says find the value of x. So if you notice, we are given 4 angles and we are looking for the 5th angle. So the first thing I want to do is find the number of degrees in a 5-sided figure. A 5-sided figure is a pentagon. So again, the first thing I want to do is figure out what is the total of the number of degrees inside of a pentagon. So I'm going to do n minus 2 times 180, but I'm going to solve it where n is equal to 5. So it'd be 5 minus 2 times 180, which equals 3 times 180, which is 540. So there's 540 total degrees inside of a 5-sided figure, or a pentagon. So I know if I take this, plus this, plus this, plus this, plus this, it would equal 540. So I'm going to do exactly that. Take x plus 84, plus 92, plus 110, plus 100, and we know that when we add up all 5 of those angles, you get 540. So this is as simple as solving for x now. So it'd be x plus, now I'm just going to add up all of these, 386 equals 540, so I'm just going to subtract the 386 to get x by itself. And I would end up with 154. So x equals 154. So again, start with finding the total number of degrees in a 5-sided figure. Set up your equation, add up all the angles, set it equal to the total, and then just solve for x to find your missing angle measure. And now on to example number 4. It says find the measure of angle S and the measure of angle T. So notice that the measure of angle S and the measure of angle T are congruent. So if I call this X, this would also be X. So once again, we have a 5-sided figure. So 5 sides. So what we need to do is set up an equation and set it equal to the total number of degrees in a 5-sided figure. Again, in the previous slide, we figured out that there's 540 total degrees in a 5-sided figure. So what I'm going to do is add up all 5 angles, set it equal to 540. So we would have X plus 85 plus 156 plus 93, and that would equal 540. So then I'm just going to simplify and combine like terms. So X plus X is 2X, and then I'm going to take the 85, the 156, and the 93 and add them all together to get 334. So the next thing I would do is subtract the 334 from both sides. So I'd end up with 2X equals 206. So I would just divide both sides by 2. So X would equal 103. So remember, I called angle T and angle S X. So if X equals 103, then the measure of angle T is 103 degrees, and the measure of angle S would be 103 degrees. You could double check this and make sure that 103 plus 103 plus 85 plus 156 plus 93 would equal that 540 total that we knew from the beginning, and it does. Next, we have another theorem. This is theorem 8.2. The polygon exterior angles theorem. So first off, keep in mind that an exterior angle is when you extend one side and then that angle that is formed. So remember, exteriors are on the outside, interiors are on the inside. So the theorem states the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, so again, we're only taking one angle at each vertex, is 360. This is true for every single polygon. No matter how many sides there are, whenever I add up all of the exterior angles, I always get 360. So make yourself a note, for all polygons, no matter how many sides it has, the sum of the measures of the exterior angles is always 360 degrees. So when you look at example number 4, it says find the value of X. So notice that we are given the exterior angles. We know that for any polygon, when I add up all of the exterior angles, I will get 360. So in this case, we are going to take each angle. So we would have the X plus 20 plus the 112 plus the 96. We know that we add up all of those, we get 360. So this is just as simple as now solving for X. So X plus X is 2X, and then I would just combine the 20, the 112, and the 96 to get 228. So then I would just subtract 228 from both sides, so I'd get 2X equals 132. So then you just divide both sides by 2, and you end up with X equals 66. So remember, make sure you are answering the question you're asked. It just said to find the value of X, which we did that. X equals 66. And example number 5, a stop sign is shaped like a regular octagon. For part A, it says find the measure of each interior angle, and for part B, it says find the measure of each exterior angle. So first off, I want you to recognize that it says a regular octagon. So remember, regular means all interior, and now all exterior angles are congruent. So if it's a regular octagon, that means it is an 8-sided figure. So if I figure out what the total number of degrees inside the octagon is, then I can just divide by 8, and that would give me the degree of each angle inside of the octagon. So again, the first thing I want to do is find the number of total degrees inside of an 8-sided figure. So that would be 8 minus 2 times 180. So that would be 6 times 180, which is equal to 1080. So the total number of degrees inside of the octagon is 1080. So since each angle is congruent to itself and there are 8 angles, I would just take this number and divide by 8. So 1080 divided by 8 is 135. So that means that each angle inside of a regular octagon is 135 degrees. For part B, it says we need to find the measure of each exterior angle. So for regular polygons, all the exterior angles are congruent to each other too. This time, for exterior angles, we know that the sum of all exterior angles, no matter how many sides we have of the polygon, is 360. So we're going to take 360 divided by 8 to get 45. So that means that each exterior angle inside of a regular octagon is 45 degrees. So just keep in mind, you just take the total, divide by the number of sides that the polygon has. So for an interior angles, you're going to do the sum of the interior angles. So we did the n minus 2 times 180, then divided by 8 to find the measure of each angle inside. For the measure of the exterior angles, we took the total, which for every polygon is 360, divided by 8 to find the measure of each exterior angle. So that's it for this section. Make sure you jot down anything you didn't understand that we can cover in class before we move on, and we'll see you then.